All right. So in the warm-up, I've got my 1,000 key truck on my ramp, 1,000 kilogram truck. It told me to draw a diagram that's going to help you figure it out. So I drew my diagram, and then it says it experiences a force up the ramp of 5,000 newtons. And I'll put that going up the ramp. Y'all looking? Ty, you looking? And then the force down the ramp, 2,500 newtons. So this arrow is about that much. So 2,500 is half that long. There you go. 2,500. And oh, it kind of tells me part of the answer there. It will experience an acceleration up the ramp because the force up the ramp is stronger than the force down the ramp. I guess that's right, isn't it? 5,000 is bigger than 2,500, so it'll accelerate up the ramp. That doesn't necessarily mean that it's stopped and it's going to speed up that way. It could be already moving this way and it'll speed up that way, or it could be rolling down the ramp and accelerating up the ramp would mean that it would slow down and stop. If it doesn't speed up this way, that means if it slows down this way, that means it's accelerating that way. So it wants us to find the net force. So if we got 5,000 this way and 2,500 this way, did y'all figure it out? What's the net force?
7,500.
That's close. You have to subtract him.
Oh.
It's
250.
yeah, 5,000 minus 2,500 makes 2,500 this way. So my net force equals 2,500 up the ramp. So the way I like to think of it is there's 5,000 this way, and it has to overcome this 2,500 pushing against it. So after it overcomes that, it has 2,500 left over. That's why we subtract it. So cool. So now it asks me a follow-up question. What would be the acceleration of the truck? All right, so we know stuff about the truck. We just figured out the force on the truck. The net force is 2,500 newtons. It told us the mass of the truck. That's 1,000 keys. And it's asking what's the acceleration. So it's got F and M and A. We're going to use F equals MA. Like I said at the beginning of the check-in. Force is 2,500. Mass is 1,000. And A is what we're looking for. So it says 2,500 equals 1,000 times A. I wanted to say equals A. It says A times 1,000, so I'll make that cancel by dividing both sides by 1,000. One on top, one on bottom. So it just says equals A. 2,500 divided by 1,000 makes 2.5, and that's acceleration. And acceleration's in meters per second squared. So I gotta write meters per second squared. And there we go. That's my answer choice.
What was the first one? It was.
The net force was 2,500.
Yeah.
Mm-hmm. So 2 steps. First you had to subtract, and then you had to divide. But all these are reviewing for the CTBA. There's some that are like these on the CTBA. The thing that we're doing today, I guess I'm going to erase this so we don't have 2 things up here at once. So what we're doing today is just like yesterday and the day before, except we're doing both at the same time. So on Monday, we did potential energy using the potential energy formula. No, there, okay. This one, where potential energy is in joules. Are y'all looking? Look, please. Bless you. Potential energy is in joules, and remember this always has to be positive. You can't have negative energy because it doesn't make sense to say, I have 5 joules in the down direction. That's just how many units of energy you have. So that's got to be positive. That's energy. That's gravitational potential energy. Remember that's just one number even though it's 3 letters. Mass is in kilograms. G is always that negative 9.81 because gravitational potential energy is about gravity because it's how much things have the potential to fall down with. So that's negative 9.81. H is height in meters, and remember when you put the height in of something to figure out how much gravitational potential energy it has up there, you have to make it negative. So if this is 2 meters tall, you say negative 2 meters. So yesterday we started doing the KE stuff. And this is, you'll either solve for KE or you'll solve for mass. KE is energy in joules again. Mass is in kilograms and velocity is in meters per second. Don't forget this squared. You gotta remember that squared. Whenever it asks you for velocity, and it'll do that quite a bit, plug everything in and then simplify. 1/2 times 10 is 5. And now it says v times 5 over here, or v squared times 5. So I want to make that 5 cancel, so I'm getting v by itself, getting closer to the answer. Since it says v squared times 5, I divide both sides by 5. And then those will cancel, and this left was just v. And 20 divided by 5 was 4. That's how I got down here. Now, here's something I didn't say yesterday that I want to add today. Your math teacher wouldn't say the square root of 4 is just 2. What would they say? Because 2 times 2 isn't the only thing that's 4. You can have the number that's times itself is also 4. So you could have positive 2 times positive 2, or what?
1 times 4.
If it's the same number, though, you could have negative 2 times negative 2. That's also 4. The negative times a negative is a positive. So your math teacher would say the square root of 4 is plus or minus 2. Since we know, if this thing told us that this object was up high and you're trying to figure out how much velocity it had at the bottom of its fall, we know that in this case, the square root of 4 to find this velocity would be negative 2, because we know that object is moving in the down direction. And that still works, because negative 2 times negative 2 is positive 4. But other than that, it's just the same as yesterday. If it asks for kinetic energy, use the kinetic energy formula. If it asks for velocity, use the kinetic energy formula, because that's the only one that has velocity in it. This one doesn't have velocity. Likewise, if it asks for height, use the potential energy formula. This one doesn't have height. And if it asks for potential energy, use the potential energy formula. That's about it with this. Please start that PE and KE assignment.